drop it too far and you can't hear me anymore, just let me know. I don't pay attention like that. So my name is Martijn Pieters, and may be recognizable more as the icon as the you see on the right here. I sometimes answer some questions on Stack Overflow. I'm also independent consultant, mentor, architect, and I do a lot of work through a platform called Arc that enables me to do remote work, freelance work. It used to be called X. And this is about a project I did and lessons learned through that platform. So a customer approached me and asked me to build a little application for them. They wanted to collect data from a very wide range of internet sources. Doesn't really matter what we were collecting, but it was going to be about, they wanted to scale this to 10K sources and pull some information from each one of them about twice a minute. Could I do that? I just need to be offline analysis. Just get the information out, put it in the database, done. Of course you can do this with Python. I use asyncio, and the data goes to PostgreSQL with timescale DB, time series database. We do all sorts of fancy stuff with that, and we monitor the whole thing with Prometheus and a Grafana dashboard. So log aggregation into Papertrail, and that's running today. It's working great. We're scaling up. Currently at 2K sources. So it runs on a single machine though. We started with a single VM machine and we're still running on a single VM machine. It's just a T2 large, 8 gigabytes, 2 CPUs. And it's doing nothing. It's a load of 0.1 average in 15 minutes and it uses 1 gigabyte. So we can easily scale to 10 gigabytes. So yes, asyncio is great for doing network stuff. Now, this is not a talk about asyncio as much. Not as much about why you want to use asyncio. Asyncio is great for to do asynchronous concurrency model is for networking stuff like this, where you have to wait for remote network responses that may or may not come, and switching between all those tasks. Asyncio is great, and you don't have to do any callbacks thanks to asyncio wait. No callback hell. But there are some small downsides to asyncio. I'm not going to go into the whole Curio versus asyncio talk either. I'm talking about just general good software development practices. Asyncio components, you can't just create let's say, one global database connection or pool, whatever, because all those components need to know the loop beforehand. If there's no loop running and you create an asyncio lock, and you try to use that lock in a loop later on, you get exceptions because it's the wrong loop. You cannot create your components until the loop has been created. That creates spaghetti code, really. This is a very small example. Real examples would be much bigger. You get big functions that create all the different services, call awaits, pass along configuration and a queue and everything else, and then you have 2 queues and 3 queues, and it becomes unmanageable. It becomes something you don't want to extend or maintain long term. I don't want to. I want something new. I want something different. I'm used to Flask, where you make a module, you put in a blueprint, you register some stuff to it, you make an extension, and they are all global, sort of. Right? Because Flask manages this for me. It says, new request, I'll put in a context. And when you import the database, or you import the current app to get some configuration, you get the right object. Can't we have that with asyncio too? Sure you can. With some callbacks. Okay, not really callbacks. It's not a callback hell. It's not event-driven stuff. But it is event. It signals. If you can manage an application lifetime, you can have globals for your components. So I created an application class. It loads configuration, and the application class can be accessed throughout the application, on the code, and you can find the configuration I register components to. And then I just use async with, so a context manager, to manage the lifetime of the application. The main entry point creates the application, starts the context, starts the application. If the context exits, everything's torn down for me. Nice. So what does an application look like? This is really code that more or less reflects what the actual application is using. It loads some configuration in a factory method, factory function. Together with the application, I can change the configuration for this. If I need to do an integration test and that needs specific configuration, like I want to switch to a SQLite database, I can whatever. I can do so, and I have imported my components that are going to be application global and registered. So managers, queues, whatever, added to the app. The app is now responsible for managing their lifetime. And then start it. And in this case, the main loop doesn't have to do anything else. I'm just waiting on the future. It's just sits there forever doing nothing because everything else runs. And then you have components. This is mocked up one. Really, what we call, we don't really attract the number of Vikings and span, but you get the idea. There's a class that defines the component functionality and state. And there's a class method that says, at this point we want to create this component. And that can be a coroutine. So I can, because I know there will be a loop, I can do everything I need to do that maybe needs a loop, maybe needs to do things asynchronously. So I can start a component, I can register a callback, a signal handler for when the component needs to be unloaded, so the application ended, put password configuration, and create my instance. This makes much nicer code, because no longer I have to do this, handle this in the main entry point. I can just use configuration to maybe use some components or not use components, or switch things on, switch things off, but that's now encapsulated into specific separate modules. Of course, I do have to do all the things that are not global. All those internet sources, pulling those things, doing tasks for them, handling timeouts, handling graceful retries, whatever. So there's a little boilerplate there. You have a queue, you have to take tasks from that queue, handle them, handle exceptions, everything else. You want to be able to start and stop workers, you want to scale up and scale down, whatever. So there's a separate class that handles a queue worker, that handles queue tasks. All it does is you give it a queue and you give it a coroutine that handles each separate task. It encapsulates everything else. So the workers execute the work as the queue gives it to them. And all I have to do is define a coroutine that says this is what this one item, how handling one item does. So it can access things like the database. It can, because it's a global component. It can handle different queues. If you go to the Cabernet cave and you find yourself faced with a rabbit, you may want to call for the Holy Grenade of Antioch. So we put it into a separate queue. How did other queues handle? That's something I can put into a different component, different module, different tests, different everything. It's encapsulated, it's nice and separate. And I just have to run register my initial workers within the application, because the application is responsible for workers. And I can create more queues, I can create more workers that handle separate queues. I give them all their own unique IDs, so I can look them up, list them on the dashboard, whatever, and trace how the application is behaving and how workers are handling tasks. So as they handle tasks, we want to know how we're doing. Don't want to have tasks taking too long, or want to know how many we're handling. I showed that vague screenshot of the dashboard. How does that get filled? Well, we have metrics. In this case, chose Prometheus because it looks sexy. Clients like sexy things. There was a financial institution involved here, and they like pretty pictures of things running well. So Prometheus pulls from metrics. It works best if it can ask your application itself, how are you doing? What are your metrics? Luckily, there's an existing project called Prometheus Async, and that already has everything packaged for you. All I have to do is create another component that would start installing it. And then throughout my application, I create gauges, histograms, counters, whatever, which are just more globals, and the library takes care of funneling that data back to its monitor. In this case, I can't separate metrics out of, I can't have multiple applications running and all have separate metrics for them. That's something we may have to solve in a future iteration on the project. So, paper trail takes all the logs, we aggregate logs. In this case, there's this one app, advanced, it gathers the data, but there's other apps too. So you want to have logging, you want to know when things go wrong, you want to know if there's any bugs that you may have overlooked, make a search in there, whatever exceptions you want to look at. The logging is not asynchronous. The Python logging library does not have any async await coroutines in there. It will try and write things synchronously. That's a problem, right? How do you handle that? There are libraries that try to make logging asynchronous. They replace the whole handler system and everything, and suddenly everything has to be away. But it's a kludge. It doesn't quite work. It's messy, it's buggy, and it's not really needed. Logging is not the main focus of this application. It doesn't produce that many messages, so I just put it into another thread. And that's very simple, because the standard library already has the facilities to do so. It has a queue handler and a queue listener. You give the handler to your logging apparatus, and instead of doing I/O, it immediately puts it into the queue and continues. It is straight on. Your application can continue to be unblocked. And a separate thread has a listener that then takes messages from the queue and writes it to whatever other handlers you want to have. So literally, I have a function that just takes the existing handlers after I've configured them, moves them to the queue handler, the queue listener, and replaces the original handlers with the queue handler. So everything goes off from the main thread into a separate logging thread and takes care of it. I wrote about this before, and I have a blog post that has the details on this, so I didn't put it all on the slide. But it should be available if people want to copy me on that one. So I talked about exceptions briefly. People make mistakes, me too. There will be bugs, tests you don't. In this case, we did very little testing because there was a very, very tight budget. There was a proof of concept, so there was definitely a need to catch exceptions and figure out what was going wrong. If you do not catch exceptions in your task handler, they will just sort of disappear. So I did put in try except and then logging the exception. But you want to not catch the cancelled error. Async I/O, when it cancels tasks, when you stop your application and it starts cancelling tasks, it raises in the task an exception just to tell you, you may want to clean up your resources. You don't want to silence it because then your task just goes on. So you want to put in an exception for the async cancel error. Even better though, you could just say, I'm not do a blanket try except. I attach it to the task. So when you create a task, this is an async I/O task, you can always add a callback. So we're going back to some callbacks. But the callback is told what happened with this task. Did the task exit cleanly? Did the task have an exception? If it has an exception, log it. If you don't do this, asyncio will be nice to you. It will say, that, hey, there's a task here with an exception. It was never handled. You want to do something with that. But you won't see it until your app is exiting. And that's usually too late. You don't want to have to tear down your whole application just because one resource at one internet site gave you an unknown response back that you didn't properly handle, and therefore that one worker exited. I'm quite proud of what I've built here. So I've agreed, the client has now agreed that I can do this, and I've been sort of working on this, but I haven't committed fully yet, but I'm releasing this as a new project called Collegial, where you can start building your own applications like this and use that. So that's going to commit to you here soon, this week I hope. As I said, I learned many tests, and I now have the right test because I'm a perfectionist and I want to present a better picture. So that's, the repository is there, but it's very, very, very empty. So, any questions?
Thank you very much, Martin. Does anyone have any questions for Martin? I will start this off. You mentioned the repository coming to a commit near us soon. Is there a particular contribution that you were quite keen to receive in a particular area?
All contributions are always helpful. I'm not the greatest documentation writer, so the Sphinx structure is there, and a logo. I love a logo.
Any other questions for Martin?
Did you compare?
We'll just let you answer and ask it in the mic for the recording.
Did you compare using async logging to just letting it go to the kernel?
To the kernel.
Did you check what latency changes you got?
Logging to the kernel, and I'm not entirely following.
So if you just do the write and the kernel takes it off your hands compared to doing the async and the queuing?
Do the thread. I haven't actually taken the native performance measurements for those things. At some point we did get a particular cluster of sources that were all at once, as one body, calling it a day, but in a way that would not actually be counted as going out of business. And every time we did that, that logged an entry. So we logged entries 2 times a minute for about 100 different sources, and they were using the free tier of Papertrail, and within 2 days we had filled it. So there was quite a large amount of data that we were writing there, and I don't think that would have been, if that was on the main thread, I don't think we would have been pulling the remaining nearly 2,000 sources as efficiently as we would have done. I think the load would have gone up. But that's an assumption.
You're logging to the network?
We're logging to some data to the network, yes. There's a separate call going out for Papertrail.
Any final questions? Okay, let's thank Martin one more time.